remember it fall down or less than 5%. And here also you're going to perform your calculation up to 4 decimal points. Okay, so when you're going to start with question here to be solved, so remember it's false position methods. Don't memorize the equation. It's going to be given in the appendix. So to start, first when you are looking at the equation itself, remember that we are saying it's to find the root of the equation. You need to get the function it's equal to the value of 0. So that means you need to find the function with the value of x to be equal to 0. In my case in here, the equation it's given here, it's r, it's equal to this term here. So that means I need to move this value of r because the value of r is a constant. It's given, it's 0.5. So I will move this r to be on the right side of the equation, so it will become as a function. So the r, it's going to be moving here. So the function will be equal to this term, minus r. When you get this one, so this means you are going to start with the false position methods. Remember, it's r is equal to 0.5 and p is equal to 4.5. Okay, and the two initial values is given to us. It's x lower is equal to 0 and x upper is equal to 0.6. So what's our target for the false position methods? I need to find the root. I need to find the value of xr. How I can find the value of xr? Using this equation here. So to fulfill this equation, to get the new value of xr, it's equal to the x upper, which is the value it's already given here, 0.6, minus the function of x upper. I don't have this value yet. X lower, yes, I have, it's 0, minus x upper, yes, it's 0.6. Over the function of x lower, I don't have this value, minus the function of xu, I don't have this value. So that means I need to get what's the value of the function at x upper and what's the value of the function at x lower. So before you can find the value of xr, I need to find the function of x lower. So that means this function when x is equal to 0. So that means the function when x is equal to 0, you look at here, so it's going to be 2 times the value of p, so 2 times 4.5 over 2 plus the value of x, which is 0, times 0 over 1 minus 0, minus the value of r, which is 0.5. So the answer is going to be, I want you to try by calculator, substitute the value of 0 or the value of x lower inside this function here to get the answer of x lower. You can write the answer also on the chat box if you don't have a mic. Perfect. The answer is going to be negative 0.5. So the function of x lower will be equal to negative 0.5. Okay, so I get these terms here. But for this equation, still missing the function of x upper. So I need to find when the function is equal to 0.6, what this function is going to be written, what value. So can you try? Find the value of x upper. And also you can write the answer at the chat box. So this means again to put the value of all the x's here, it's 0.6, 0.6, 0.6. The value of p, it's 4.5. The value of r, it's 0.5. So you're going to get the answer of the function of x upper. Okay, but remember that is we are saying that your calculation is supposed to be up to 4 decimal points. The answer is 2.2908. So it's mean stick to this one. Perform the calculation up to 4 decimal points. Your answer is correct, but is just only having 1 decimal point. Okay, so now I have x lower, I have x upper, I have the function of x lower, and the function of x upper. So now 1, 2, 3, 4 values. I will put all these values inside this equation to get the new value of xr. So this means the value of xr is going to be, take your time, get the value of xr. Okay, getting the answer. You're supposed to get the answer of 0.1075. X upper is 0.6 minus the function of x upper 2.2908 times x lower minus x upper. So 0 minus 0.6 over the function of x lower, which is negative 0.5, minus the function of x upper 2.2908. Your answer is 0.1075. Check your answer back. Okay, so now we are trying the value of the function of xr. So now you get the answer here. Remember that it's to say that when we are going to narrow our search, or when you are going to bracket or to find the root, you need to find the function of x lower times the function of xr. So you are going to see if the value of the function of x lower times the function of xr greater or less than 0, then you're going to exchange the value. So in our case in here, the function of x lower times the function of xr, it's going to be greater than 0. So if function of x lower than the function of xr greater than 0, so it means next iteration, x lower will exchange the value with the xr. So let's see how. So negative 0.5 times negative 0.2511. So the answer is greater than 0. So it means next iteration, this value of x lower, it will take the value of xr here. And x upper will remain the same. So it will be, it's equal to 0.6. Then you are going to iterate one more time. So you need to find the function of x lower and the function of x upper. Then you are going to find the value of xr using this equation. Then you are going to find the function of xr. Then you are going to times. After that, you are going to calculate the error. This is important. So here, you are going to calculate the error. Okay. So let me show you the answer of the error. You're supposed to get the error for the second iteration. It's 31%. Remember here, they are saying is the acceptable approximate error supposed to be less than 5%. So here it's 31%. So that means you are going to iterate another time. Okay. So I will reveal this iteration here. I want you to now to try to do the second iteration, third iteration, and fourth iterations till the error is less than %. Okay, how actually I can get the error? It's based on the value of XR. XR new, which is 0.156, minus the old one, 0.1075, over the new one, 0.1561 times 100. So you get the answer is 31. This is how to get the error. New value of XR minus the old value of XR over the new value of XR. So you need to iterate till the error less than 5%. Okay, I will give you a time, let's say about 10 minutes or 15 minutes to get the answer. Then you can check your answer with my PowerPoint file here. This is your second iteration. You look at the error is still 12%. So you are going to iterate one more time. So when you are looking at this value, still the value here it's greater than 0. So this means still x lower will take the value of xr and x upper will remain the same. Then you will find the values. Any one of you achieve the final answer? Okay, take your time. So you have about 2 iteration or one more iteration to go. Okay, some of you have achieved the answer. So let me go through the iterations here. So this is the values. Will the function of x lower and the function of xr it's greater than 0. This is the error. 5.5, still higher than 5%. So this means you are going to iterate one more time. So this is x lower, this is x upper, xr, and this is the values of the function. Still the error it's less than 5%. So this means you're going to stop. So the answer here is the value it's 0.19. This is the value if you put in the function will be equal to 0. Okay, so now you look, this is the ideal answer of this question. During the midterm exam or during the final exam, you can see how many times you iterate, about 1, 2, 3, 4 times. Okay, each time you iterate, you have to calculate the error because you are going to have about 1 marks just only to get this column. So 1, 2, 3, 4. 4 marks just only to calculate this error. And without calculating the error, you're not going to know when you're going to stop. Okay, another advice, because your midterm exam is about 1.5 hours. When you are solving such a type of questions, you're going to iterate. No need for you to write all the steps of the calculations. What you can do, just show sample calculation of the first iteration. So just show it manually, how you solve, how you get the equations, how you get the values, how you get the answer. And the rest, you should make it in a form of a table. So this is going to be fast for you to get the answer. So this is my advice if you want to follow, to save your time, because 1.5 hours is not enough sometimes to solve for the 2 or 3 questions. So show a sample of calculation, and the rest you can put the values in a form of a table. Okay, so that was the answer of the bracketing method. Let's see the question coming from the open methods, which we are going to use the second method. We are having here a function. That function is already there. It's ax. It's a polynomial, so it's 0.5x cubed plus 3.5x squared minus 37. Here it's x represent the concentration of the solution. Here you can see that even though we are saying that this one is an open method, but it has 2 initial value. X initial it's 3.5, and xi minus 1, or the backward finite divide, it's equal to 1. So with these 2 initial values, you need to estimate the concentration of the solution using the second method. And here is the asking for the approximate percentage error. It's less than 1%. Perform the calculations up to 4 decimal points. So to solve this one, the equations in here is in somehow exactly like the value of false position methods. Here we need to find the value of xi plus 1. What's the parameter is giving to us? X initial is 3.5, and x minus 1, or x backward divide, is equal to 1. So when we are looking at the equation here for finding the new value of x plus 1, I need to find the function of x when it's equal to 3.5, and also I need to find what's the function of x minus 1. So this means when the function is equal to 1. So same like what we have done before. First, when x minus 1 is equal to 1, so I will put the value of 1 inside here, inside the function, to get the answer. So 0.51 cubed plus 3.5 times 1 square minus 37. So I will get the answer of x backward is equal to negative 33. So the value here is going to be negative 33. And x initial is 3.5. So here it's 3.5. Here it's negative 33. Function of xi, not yet, I don't have this value. So I will try to find when x is equal to 3.5. So this means 0.5 times 3.5 cubed plus 3.5 times 3.5 square minus 37. The answer is 27.31. So now I have the values in here. So xi plus 1 will be equal to x 3.5 minus 27.31 times 1 minus 3.5 over negative 33 minus 27.31. So I will get the answer of x plus 1. Can you find what's the answer of x plus 1? And you can write your answer at the chat box. Okay. Some of you getting the answer. 2.36. Okay, good. So some of you getting the answer. Now you need to calculate the error. So the error here is x new minus the x old over the x new. So x new here it's xi plus 1, which is 2.3679, minus the old one, which is the initial here, it's 3.5 over the new one. So the error, it's 47.8%. Still too far to get less than 1%. So this means you are going to iterate one more time. So to iterate one more time, for the next iteration or the second iteration, x backward will be equal to 3.5 and x initial will be the x new. So x backward will be equal to 3.5 and x initial will be equal to the new one, 2.36. It's coming here. Then again, I'm going to try to find what's the function of the backward which is going to be here exactly this one, 3.5. So it's going to be equal to this answer here, because 3.5, the function is 27.3. So this means you already calculated this. So you need now to find what's the answer when this function is equal to 2.36. So find the answer and try to find the answer of x plus 1 and calculate the error. Okay, take your time. Anyone get the answer? Okay, let's see. Okay, so the answer of x plus 1. And the error? Okay, good. So still, the value here, it's not less than 1%. So you're going to iterate one more time. So to iterate one more time, so the third iteration, x backward will be equal to the value of 2.3679. And x initial will be equal to the new value, which is 2.6874. And again, you're going to find the values. This value you already calculated for the backward because you already have it here. Then you're going to find the new value of x plus 1 and x. So you get this answer. Then you are going to find x plus 1 and you will find the error. When you are going to find the error, it's 2.68. Okay, so I will leave now the last iterations to solve it fully. So your initial value of x and initial value of x initial, and this is the value. So I want you to calculate till you find the last value of the error. And this is the last thing for our tutorial for the finding the roots of the equation using bracketing and open method. Okay. .754. Perfect. So now the last answer is, what's the error? Okay. This is the error, 0.26. So when you are looking at this value and here the question, your acceptable approximate percentage error must be less than 1%. You already achieved the error, it's 0.26. So that means the value of 2.75, this is the value. If you put it here inside this function, almost is going to be equal to the value of 0. Then you are going to get full marks. So each time, don't forget to calculate the error for each iteration. Okay, so that's all for this chapter of finding the roots of the equation. Next class, when you are coming back from the Hari Raya, we are going to have a new chapter, which is going to be linear algebraic equation. It's a very important class because the methods that we are going to learn from the coming chapter, we are going to use it to apply it for class of optimization and also for the curve fittings and solve for the simultaneous linear algebraic equations. So we are going to use the methods for 3 other chapters. So it's very important to be attending the class on the after Hari Raya. So if you have any questions, please ask. If not, this is the last thing for today. So if you don't have any questions, before you leave, I want you to write your name and also the student ID for attendance today. Any question about open methods or bracketing methods?
No, sir.
Okay, thank you very much. Please write your name, student ID in the chat box for attendance. Salamat Hari Raya all. I will see you inshallah face to face when you are coming back. Take care.
Thank you, sir.
Thank you. Bye-bye.
Thank you, sir. Selamat Hari Raya.
Selamat Hari Raya. Thank you. Bye-bye.